the points on the ellipse x square plus 4y square equals 4 that are farthest away from the point 0, 1. We don't have to graph the ellipse. Anyways, point means x and y coordinates. So we want to determine x, y. It looks like we have more than one point here, because points on the ellipse that are farthest away from the point. So the distance between this point x, y and 0, 1 is the largest. So the point we assume x, y. So that's why we start. And I'll show you later graphing this as well, just to justify, just to show what's going on here, okay? So let the point be x, y. And we have the ellipse where x square plus 4y square equals 4. So this is the constraint, okay? Constraint means relationship between x and y, which is here. X square plus 4y square equals 4. And we want to solve for one variable. Let's solve for x square, x, because there is no number. That means we don't get a fraction. Subtract 4y square from both sides. So x square equals 4 minus 4y square. Now take a square root of both sides. So we get absolute value of x, but we write that plus minus on the other side. Square root of 4 minus 4y square. Okay, this is not 2 minus 2y. We cannot take a square root because this is negative sign. It's not a product. So anyways, as soon as we get y later, we find x from this relation. So, and we use this in the objective function as well. Next, we are trying to determine the distance between x, y and 0, 1. Okay, I'm just showing you here the distance, and we want this distance to be the largest because we want the point to be farthest away. So from algebra, we know the distance between these 2 points is given by x square root of x2 minus x1 square plus y2 minus y1 square. Or we can think x minus 0 square is the same thing, plus y minus 1 square. Okay, this is the distance between these 2 points, and we want to maximize this. So instead of maximizing this distance, because it involves square root, how about writing the inside and maximize this? Okay, so let me, this one is kind of side work. Here the objective function is distance, because we want to maximize the distance here. Okay, distance between 0, 1 and our to be determined point xy, and the distance is given by this formula, pretty much x minus 0 square plus y minus 1 square, using the distance formula. Instead of working with a square root, we can just maximize the function inside this radical sign. If the inside function is maximized, then square root of that will be maximized as well. I mean, we can work on this, but it will be more complicated because of a square root. So let the function be inside as a function of, okay, I don't know, it will be a function of x. It could be a function of, in fact, x will be replaced by y. So it will be a function of y, or you don't write just f. And it will be a function of y because this constraint, okay, we are writing x in terms of y. So this will be a function of y, but if you just write f, that's fine. I'm just taking inside x minus 0 square means just x square plus y minus 1 square. And we would like to maximize this, okay? Optimize this, in this case maximize. When we maximize this, then the distance means the square root of this will be maximized as well. Now looking at the constraint, we can replace x square. In fact, we can replace from here, or this is x square, we can go from there as well, same thing. If we square both sides, then plus minus will be plus and the square root will be gone, so 4 minus 4y square. So this one is x square is given from here, 4 minus 4y square plus, if you want we can simplify this, okay? It's not necessary, but let me do y minus 1 square means multiply y minus 1 by itself, okay? As a FOIL, we get y squared minus y plus 1. So this is in fact y squared minus y means minus 2y plus 1. Now let's simplify this. Negative 4y squared plus y squared, negative 3y squared, and negative 2y, 4 plus 1, 5. Okay, we have the objective function here and we would like to optimize, in this case maximize. Whenever we want to optimize a function, we take its derivative, which is easy here, just negative 6y minus 2. Derivative of 5 is 0. Now we set the derivative 0. That means negative 6y minus 2 equals 0. Let's solve for y. Add 2 both sides and divide by negative 6, because this is negative 6 times y. So y is add 2 divided by negative 6, and this is, when we simplify, negative in the front, 1/3. Okay, we got y equals negative 1/3, and when we plug y back here in the constraint, we get the corresponding x values. In fact, we get 2 x values. So with one x value positive, y, one answer, one x value negative, and this y, we have another answer. Now we need to verify this y indeed maximizes the distance, because we want to find the point xy that is farthest away. So to show y equals negative 1/3, indeed maximizes f, we find second derivative. We can go for second derivative. Okay, so we already have first derivative found here. Let's find second derivative. That is negative 6. Okay, which is always negative regardless of the value of y, because there is no y. This is less than 0 for any y, but for our y as well. For our y, second derivative is negative. That implies y equals negative 3 maximizes the function y, the function f, sorry. And when it maximizes the function, then it maximizes the distance, and thus the distance, it maximizes the distance. Okay, thus the points are, so our answer, thus the points means x and y coordinates, those are x, y. Now we need to determine x from, because y is negative 1/3, we found here, or here. Go back and plug in here. So x is plus minus 4 minus 4y squared. Let me do over here. So x is plus minus 4 minus 4y squared. That is plus and minus 4 minus 4 times y is negative 1/3 squared. 1/3 means 1/9. 4 times 1/9 means 4/9. Plus minus, we can combine these two fractions because 4 is 4 over 1. So 9 common denominator, 9 times 4, 36 minus 4, 32 over 9. Plus minus 9, okay, it's a perfect square number, so 3 on the bottom. 32, okay, 32 is 16 times 2. 16 is a perfect square number, so 4 root 2. So this is 4 root 2. So plus or minus 4 root 2 over 3. So we got 2 points. X is 1 plus, we can write 4 root 2 over 3, and y is negative 1/3. Y is fixed. Okay, and negative 4 root 2 over 3, and y is the same, y negative 1/3. Okay, these are the points. Okay, I mean, this is it. Okay, done. But if you want to show what really happened in this question, so we were given an ellipse. Okay, ellipse is x squared plus 4y squared equals 4. That is x squared plus 4y squared equals 4. Divided by 4, we get x squared over 4 plus y squared equals 1. Okay, so we have an ellipse something like this. Our x got 2, okay, and y got 1. And we are looking for a point on this ellipse that is farthest away from the point 0, 1. And 0, 1 is here, by the way. Okay, this is 0, 1, and obviously farthest away means somewhere here. Maybe I would think here and here. In fact, 4 root 2 over 3 minus 1/3 means looks like this, and negative 4 root 2 over 3 minus 1/3 may be this. Okay, both points got the same y coordinate, and the x coordinates are positive means on the right, negative means on the left. Okay, but once you find these points, you are done.